Why is lithium less reactive than potassium? Well, reactivity is all to do with how easy it is for an element to get a full outer shell of electrons. So potassium is more reactive, so potassium, it's easier for it to get a full outer shell of electrons. So let's get that point in there straight away. It is easier, or it is harder, if you're going to use the lithium example, it is easier for potassium to get a full outer shell of electrons. Now we need to explain why that's the case. Well, to do that, let's just remind ourselves where these things are on the periodic table. Both lithium and potassium are in group 1 of the periodic table. Group 1, there's our 1, of the periodic table. That means they have 1 electron on their outer shell. So therefore it's easier for potassium to lose its outer electron. It's easier for potassium to get a full outer shell of electrons to lose its outer electron, singular, only 1 electron. So why is that the case? On potassium, potassium is bigger, so potassium is further down the group. So potassium is further down the group, or lithium is closer to the top of the group, further down the group. So the further down the group you go, the more shells of electrons there are. It has more shells of electrons. So because it has more shells of electrons, its outer electron, which is of course negatively charged, is less strongly attracted to the nucleus, which contains all the protons, which is positively charged. Why? Because it's further away. You could also use the argument of shielding here. So potassium's got more shells, so there's more inner shells to shield that outer electron from that negative outer electron from the positive nucleus, meaning it's more easily lost. Either way, a very common question, worth getting that answer learnt. All these questions on elsham-chemistry.com.